Today, we will be discussing the sampling distribution of the sample mean for a normal population when the variance is unknown. Before diving into calculations, let's quickly review what this means. Suppose that all possible sample size are drawn from a population with mean and standard deviation. Then the means obtained from all these possible samples will make up a sampling distribution of the sample means exhibiting the following properties when variance is unknown. So in statistics, the sampling distribution of the sample mean refers to the distribution of all possible sample means that can be drawn from a given population. If the population follows a normal distribution, the sample means will also be normally distributed. But what happens when the variance is unknown? That's what we'll explore today. Now, let's go step by step through our given problem. A teacher gave a 25-item summative test to a class of 10 students. The result of the test is 10, 12, 15, 17, and so on. Find the population mean A, variance B, and the standard deviation C. For solving the population mean, we have a formula of m equals the sum of all x values divided by n, where x represents the sum of all values, and n is the total number of values. Now let's substitute our given values. M is now equal to 10, 12, 15, 17, up to 25 over 10. So we're going to add all these values and divide it by 10, and it equals to 18.5. So the population mean is 18.5. Next, let's determine the variance, which measures how much the values deviate from the mean. The formula for the variance is sigma squared equals to the sum of x minus m squared divided by n, where x represents each individual value and m is the mean and n is the total number of values. To calculate variance, we subtract the mean from each value, square the result, and sum everything. So variance is equals to 10 minus 18.5 squared plus 12 minus 18.5 squared plus up to 25 minus 18.5 squared divided it by 10. After computing the square differences and summing them, we get variance is equals to 247.25 over 10, which equals to 24.73. So the variance is 24.73. Finally, we calculate the standard deviation C, which is simply the square root of the variance. The formula is sigma equals the square root of sigma squared. Substituting our value for variance, so we got to square the 24.73 and equals to 4.97. So the standard deviation is 4.97. So we found that the mean is 18.5, the variance is 24.73, and the standard deviation is 4.97. So these values help us understand how the test scores are distributed among the students.
Example number 2. Random samples with size 3 are drawn from a population having the value 10, 16, 21, and 23. Find the mean and the standard error of the sample mean. A. Solving for the population mean. The formula to calculate the population mean is mu equals the sum of all values in the population over the number of values in the population. The values in the population are 10, 16, 21, and 23. Add up all the values. 10 plus 16 plus 21 plus 23 equals 70. Count the number of values, which is 4, since there are 4 values. Now, divide the sum by the number of values to get the population mean. Mu equals 70 over 4 equals 17.5. So, the population mean is 17.5. Thus, the sample mean is equals to 17.5 because they are the same. B. To get the standard error, compute first the population standard deviation. The formula for the population standard deviation is sigma equals the square root of the quantity of x sub I minus mu squared. We already know that the mean is equals to 17.5. Now, let's calculate the division of each value from the mean. X sub 1 minus mu. So, the x sub 1 is 10 minus 17 minus 5 equals to negative 7.5. And ang x sub 2 is 16 minus 17.5 equals negative 1.5. X sub 3 is 21 minus 17.5 equals to 3.5. For x sub 4 is 23 minus 17.5 equals 5.5. Square each of these deviation. So, negative 7.5 squared is equals to 56.25. And negative 1.5 squared equals to 2.25, and 3.5 squared is equals to 12.25, and 5.5 squared is equals to 30.25. Sum up this square division. 56.25 plus 2.25 plus 12.25 plus 30.25 equals 101. Divide the sum of square division by the number of values n, which is 4. 101 over 4 is equals to 25.25. Take the square root of this result to find the population standard deviation. So, standard deviation equals to square root of 25.25 is equals to approximately 5.2. The population standard deviation is 5.02. C. Solving for the standard error. The formula for the standard error of the mean is the population standard deviation over square root of sample size times square root of the population size minus sample size over the population size minus 1. First, calculate the basic part. The n minus n over n minus 1 is 4 minus 3 over 4 minus 1 because the population size is 4 and the sample size is 3. So, equals 1 over 3. Now, plug in the values into the formula. We already know that the standard deviation is 5.02 and the sample size is 3. So, 5.02 over square root of 3 times square root of 1 over 3 equals 1.67. So, the standard error of the mean is approximately 1.67.
So we found that the population mean to be 17.5, and we calculated the population standard deviation as 5.02. And finally, we used these values to find the standard error, which is 1.67. So I hope our explanation was helpful. Thank you for watching.
Tam giác là tác là đánh, giam là nhốt, đánh nhốt là đốt nhánh, đốt là thiêu, nhánh là cành, thiêu cành là thanh kiều. Thank you everybody, welcome to the party.